Hey guys, welcome back to another episode of Math Unlocked with your host, Mrs. Rhodes-Grierson. So today we're looking at equivalent fractions. Now, the first thing is that what does it mean to be equivalent? We're looking at holding the same value. Holding the same value. Very important that you note that equivalent means they have the same value. So, fractions. So fractions are representing a part of a whole. Right now, I have the fraction 4/8. That literally means that there's a whole that is divided into 8 equal parts, and I had 4 of them. Now, if I want to write some fractions that are equivalent to this, it means that they must hold the same value as this. Now, I can get a number that is going to be representing an increase in the size or a decrease. So notice we're going in two different directions. I can create equivalent fractions to this, either represent bigger numbers or represent numbers that are smaller than these numbers, but it must hold the same value. So now, when we look at fractions that are equivalent to 4/8 that are representing bigger numbers numerically, we're looking at multiplication. So we're going to be multiplying to get fractions that are equivalent to 4/8. Now, I'm not going to multiply by 1 because if I multiply by the whole number 1, I'm still going to have 4/8. So I'm going to start at the next whole number, which is the number 2. Since I'm creating an equivalent fraction, it means that if I change my numerator, I must change my denominator as well, because for it to be equivalent, it means that whatever I did to the top, I must do the same thing to the bottom. So if I multiply this by 2, I'm going to get 8. If I multiply this by 2, I'm going to get 16. Now I could keep going. I could decide that I'm going to, so this one would have given me this. I could have decided I'm going to multiply by 3. What would I have gotten? I'm going to multiply both top and bottom by 3. What would I get? 3 times 4 times 3, that's 12. 8 times 3, that's 24. I'm hoping you're noticing something. That 4 is half of the number 8. If a fraction is equivalent to 4/8, it must represent, the numerator must represent half of the denominator. So my 4/8 is equivalent to 8/16 because 8 is half of 16. It's also equivalent to 12/24. And we could just decide to, what if I gave you one number and asked you for the next? What if it was the number 50? And we're looking at the fact that 4/8 is a fraction. 4 was half of 8. So if I now have a denominator of 50, what's my numerator? Since it is, so it should be half of the denominator, we could just then fill in the blank to say that that must be 25. Now notice that all these numbers that we would have written now are numerically bigger in face value than the fraction that we had here, but all of them are equivalent based on the expression that they're still maintaining, that the fraction represents half of the whole. Now, do we always multiply? No. What if I wanted to still have a fraction that was representing 4/8, but I wanted to have a smaller face value? Smaller face value. Notice that the actual true value is not changing, but the numbers that I'm looking at, they look smaller. Now, this is a way of reducing our fractions. So equivalent fractions are represented also by reducing a fraction. So now what would I do? What do you think I will do? You think I would still be multiplying if I wanted to create equivalent fractions that are a reduction of the fraction that I'm seeing? I know you've thought about it, and I know you come up with the fact that it must be the opposite of multiplication, which means that we're going to be dividing. Now, just as I always said before, that I wouldn't multiply by 1, I wouldn't divide by 1 either. Because if I divide by 1, I'm going to get the same number. So I'm going to start at dividing by the next whole number, which is 2. Remember, over this side, we said if I did the top, I must do the bottom, the very same thing. So what happens over this side is that we're now going to be reducing this number to smaller fractions that are equivalent to it. To maintain equivalence, it means that anything I do to the top, I must do the very same thing to the bottom. So 4 divided by 2 is 2. 8 divided by 2 is 4. Are they equivalent? Is the top half of the bottom? Yes, it is. Could it be further reduced? Let's think about it. When we reduce, we're trying to find a whole number that will go into both the numerator and the denominator without leaving a remainder. Anybody knows what they call those numbers? Let's think about it. Numbers that divide a number without leaving a remainder is a factor. So when we're dividing, we're looking at factors of the number that I can use to divide. When we're multiplying, we call those numbers multiples. So it therefore means that 8 is a multiple of 4, 12 is a multiple of 4, 25 is a multiple of 4. We're going this way. 2 is a factor of 4. 2 is a factor of 8 because both of them can go into them without leaving a remainder. Now, so we divided by 2, we got 2/4. Can we divide again? Well, the division is tricky, we can't use the same thing when we're multiplying, because multiplying just means grab every whole number I see and go ahead and multiply. When dividing, it's a little bit more special because I can't just grab any number or any whole number. The number that I take must be a factor of both numbers. It means that it must be able to divide both numbers without leaving a remainder. And I said both, I didn't say one, I said both. For it to be a common factor, it must be able to divide both numbers without leaving a remainder. So we use 2. I'm going to try 3. 3, 3, 3, no. 3 can't go into any of these. The only number that's left is a 2 again. So I'm going to divide by 2 again. We're divided by 2. Both numerator and denominator is divisible by 2. 2 into itself goes 1 time. 2 into... So we're dividing by 2. 2 into itself goes 1 time. 2 into 4 goes 2 times. Now, I can see that this fraction is in its simplest form, which 4/8 is actually equivalent to the fraction of 1/2, more popularly known as half. All the fractions here are representing half of a whole. So what should we notice? When we reduce a fraction, when we reduce it, all these fractions are equivalent, but there's something special about reducing the fraction. When it comes on to equivalent fractions, we can create multiple equivalent fractions from a fraction. But going in this direction has a stop. It has an end point. It's not infinite. It's very finite because they're finite factors of a number, but they're infinite multiples of a number. So we could go on ahead and multiply on and on and on and on, and they keep getting bigger and bigger and bigger. But when it comes to dividing, we are going to reach to when it reaches to the smallest form, then we stop. And that brings out a very key point. All right, so one of the key things though is that what if I'm reducing the fraction? So reduce means that I'm getting the numbers smaller. So I'm going to reduce the fraction, and we can reduce without having it in its simplest form. But generally the question will state reduce the fraction to its simplest form. So when I look at a number and want to reduce it, in order to reduce it to its simplest form, reduction means I'm going to divide. In order to reduce it to its simplest form means I need to find the biggest, the highest common factor of both numbers. So the number 8 and the number 4 and the number 8, I'm looking for what number can go into or divide 4 and 8 without leaving a remainder, and I want the biggest one. So we know that's 4, right? And if I divide the top by 4, I'm going to divide the bottom by 4. So that will go into that 1 time, that will go into that 2 times. So to ensure that it's in its simplest form, we use the highest common factor. Once you have a fraction, if you're supposed to reduce the fraction, remember that these fractions are equivalent. Once you're to reduce them, if you want it in its simplest form, we use the highest common factor. Note that I could have reduced this. I could have reduced 4/8 if I divided both of them by 2, because both are divisible by 2. I would have gotten 2/4. Now 2/4, even though it is a reduction of 4/8, it's still not in its simplest form. So to ensure that I obtain the highest common factor, I always use to ensure that I get the simplest form, I always use the highest common factor. So we can reduce fractions by dividing both numerator and denominator by the highest common factor. All right. I hope that you'd have learned something today. Don't forget to like, subscribe, and return for much more videos to come.